Hello and welcome to this session. So in this session we're going to be looking at IP addressing, IP version 4 addressing in specific. And one might ask, what is an IP address? An IP address is a logical representation of a host or a client on the network. And we basically have two types of IP addresses. We have IP version 4 addresses and we have IP version 6 addresses. That is how basically computers are represented logically on a network, or identified logically on a network. So in today's session we're going to be looking at IP version 4, and we're going to understand how we translate this IP version 4 addresses from computer understandable to human understandable. So if you're into this kind of content, remember to subscribe, hit the like button, comment down below, tell me what topics you would like me to talk about, and reach out to me via my social media handles. And let's get right into it. Now, IP version 4 addresses are represented using binary values in computers, but we humans are more familiar to decimal numbers, and IP addresses are written in a 4-dotted decimal notation. Okay, an example is 192.168.1.5. okay, that is a 4-dotted decimal notation. So IP version 4 addresses are 32 bits in length. That is when they are converted into binary, and they are divided into 4 octets, and each octet is 8 bits long. So how we basically get the length of one octet is taking the total length of the IP version 4 address and dividing it into 4. So it's 32 divided by 4, we get the value 8, and the 4 octets are represented as below, with each octet having 8 bits in length. Now, talking of structure of an octet is made by incrementing a value by itself up to the 8th bit, and we're going to start with the value 1. So 1, you increment it to itself, you're going to get 2. 2, you increment it to itself, you're going to get 4. 4, you increment it to itself, you're going to get 8, up to the 8th value, where you're going to get 128. And that is the basic representation of an octet. And what basically an octet does helps us to convert IP addresses from decimal to binary. Okay, so we're going to take an example of a 34, and we are going to convert it from a decimal to binary. Okay, so when we are converting from a decimal to a binary number, we basically go through a number of steps, and in the octet we start with the rightmost bit, that is the 128, that is your rightmost bit. Okay, and you're going to work your way downwards, and the steps that you're going to go through is take the first value, compare it to the value that you have, and ask yourself, is 34 in our case, is 34 greater than or equal to 128? If yes, take the 34 minus the 128, place a 1, and move on to the next value. Okay, if not, move to put a 0, move on to the next number, and iterate until when the condition is met. Okay, and the condition is either greater than or equal to. Okay, so that is how basically you convert, and in all positions that the condition is met, you are going to insert a 1, as we said earlier, and if it is not, then you're going to insert a 0. So in our case, if we go through the number of steps with 34, we're going to get the value 001 00010. Okay, that is our binary value for 34, and that is how basically we convert from decimal to binary. And I would advise that you go through this example once again, pause the video, go through this example once again until you understand, and then let's continue. Now, to revert to decimal, okay, that is from binary to decimal, we place the binary number on our octet, okay, and add the corresponding values where they are ones. So in our case, we got a 1 at 32, since it's 34 was greater than or equal to 32. So we took 34, we minus 32, we got 2, we placed 1 and moved on to 16, and we went up to 2 where it was equal to, so we placed a 1 at where 2 was. And to convert back into decimal, we are going to basically take the values where 1 occurred. In our case, it's going to be 2 and 32, and we're going to add them up and get back our value, which was 34, which we use in our 4-dotted decimal notation, okay, when representing IP addresses in human understandable language. So again, go through this example, pause the video, go through this example, and when you completely understand how we convert these values, then get back to the video. Okay, in IP version 4 addresses, there's some things that one would be required to understand, or sometimes that you'll frequently hear when you're talking about IP version 4 addresses. And the first one is a subnet mask, and a subnet mask helps us to identify the network part of an IP address and a host part of an IP address, and that depends on the length of the subnet mask or the IP address. Okay, we always start with the ones, which represent the network part, and followed by the zeros, which represent the host part. Now, there are different types of IP version 4 addresses, and one of them is a network address. This is a term used to define an address space in a network, okay, and an IP version 4 network address is basically issued to you by an internet service provider, okay, and this is what you basically use to subnet your network or scale it, okay. That is what we call a network address. It defines an address space in a network. I hope you are very clear on that. Now, a host address defines one usable address in a network. That is a representation of a host address. Okay, one host in the network, one client in the network. That is what we call a host address. The first usable address is the first address that can be allocated to a host in a network. We have talked about an address space, and in this address space, the first usable address is for example, if you had 192.168.1.0, your first usable address would be 192.168.1.1. That is your first usable address. That is if you have a prefix of 24. And the last usable address is the last address that can be allocated to a host in a network. Okay, so if you had 192.168.0.1.0 with a prefix of 24, then the last IP address that can be allocated to a host in a network would be 192.168.1.25. IPv4. Now there is what we call a broadcast address, and a broadcast address is used to send packets to all usable IP addresses in a network space, and this is basically helps to communicate to all. If there is a message that you need to reach to all your clients in a network, then the broadcast address is what you use to communicate with all your clients in a network. Now, talking of the prefix of an IPv4 address, or the length of an IPv4 address, what helps us identify IPv4 addresses are the classes, the different classes that IPv4 addresses are divided into, and we basically have 5 of them. There is class A, class B, class C, class E, and the class D and class E. Sorry for that. And the class D and E are reserved for other purposes. Others are research IP addresses, and others are given to institutions. But what we can basically find on the internet, and what can be assigned to us as users of the internet, are these first class 3 classes, which are class A, class B, and class C. And what helps us to define these classes is the prefix, and the prefix is basically the length of an IP address. Okay, the length of the network header of an IP address. And in class A, the first octet, we have 0 to 127, and the subnet mask is 255.0.0.0. So you can see that in this case, the network part occupies only the first octet. That is why we are saying the network header is 8 bits, and the subnet mask takes the rest of the part. And what the subnet mask helps us identify, as we talked earlier, it helps us identify the network part and the host part. So in the part where 255 is, that is the network part, and where the zeros are, that is the host part. Now in class B, in the first octet, remember we identify the classes from the first octet. In class B, the first octet will be 128 to 191 with a 16-bit network header. I believe we now understand what is a network header. And in class C, in the first octet, we have 192 to 233 with a 24-bit network header. Okay, and a subnet mask of 255.255.255.0. So you can basically see the difference in the subnet mask, and those are the basic IPv4 classes. Now there are types of packets that one can send in IPv4, and remember when we were talking about the address space, we talked about a broadcast address, and that is one type of packet that could be sent, a message to all hosts or clients in a network. Now let us start with the unicast packet, and this is a packet that is destined for one host in the network. Okay, a multicast packet is a packet sent to an address group, and you need to understand this multicast concept. Now multicast means that there is an address on the space that identifies itself and has had mutual agreements with certain hosts in a network to join a group. Okay, so if there is a message for this group of hosts or clients in a network, then they are going to access this multicast address and get information from there. So if you're sending a multicast packet, you send it to the multicast IP address, and the host or clients who are in the group, or the multicast group in the network, are going to get the information from there. So the packet that is sent to a multicast IP version 4 address is a multicast packet. A broadcast packet, we talked about it earlier, and we said it's a message that could be sent to all hosts in a network. And I believe that is all for IP version 4 addresses. Join me for the IP version 6 addresses, and see you in the next one. Thank you.